Right. So let's go to the next problem. So I think you have understood this problem. Next, write down the third question. Next one, write down third one. If the roots of the equation, write down if the roots of the equation ax square plus bx plus c equal to 0. If the roots of the equation ax square plus bx plus c equal to 0 is alpha comma beta, then from that derive the quadratic equation. Then from that derive the quadratic equation. Then from that derive the quadratic equation with roots 1 over alpha plus 2, 1 over alpha plus 2, and 1 over beta plus 2, 1 over alpha plus 2, comma 1 over beta plus 2 in terms of a comma b comma c. In terms of a comma b comma c. Right. Now look at this one. Now they have given the quadratic equation, right? Ax plus bx, ax square plus bx plus c, roots x equal to, here roots x equal to alpha, comma x equal to beta, right? Those are the roots. Now, so here they have said that in the question they are asking to derive the quadratic equation, not to find the quadratic equation. That means we have to convert this equation to the equation we want, right? So let's assume y equal to 1 over x plus 2. 1 over x plus 2, algebraic relation. Right. So if you assume this, when x equal to alpha, so in this equation x equal to alpha and beta, those are two roots. So when x equal to alpha, we can get the y value as y equal to 1 over alpha plus 2, right? 1 over alpha plus 2, and also when x equal to beta, y equal to 1 over beta plus 2. So if you look at this two values, these are the two roots that we want, right? 1 over alpha plus 2, comma 1 over beta plus 2. So when x equal to alpha, you get the first root. When x equal to beta, you can get the second root. So these are the two roots that we want. So therefore, using this algebraic relation, we can convert this given equation to the equation we want, right? So therefore, we can use this algebraic relation, right? Now look at this. Now we know that y equal to 1 over x plus 2. Y equal to 1 over x plus 2. So we can take 2 here. Then y minus 2 equal to 1 over x. Then if you get the reciprocal, we can find the value of x. Then x equal to 1 over y minus 2. X equal to 1 over y minus 2. Right. Now we can convert our equation. So the given equation was ax square plus bx plus c equal to 0. Here roots are x equal to alpha, comma x equal to beta. These are the two given roots. Now we can convert our variable from x to y, right? So when y equal to 1 over x plus 2, we can write down x equal to 1 over y minus 2, right? So instead of x, write down a. Here write down 1 over y minus 2 square of the whole thing, plus b. Instead of x, write down 1 over y minus 2 plus c equal to 0. Here roots are instead of x, now you can write 1 over y minus 2 equal to alpha. Here 1 over y minus 2 equal to beta. Right. Now take this square. Then a into 1 over y minus 2 square plus b into 1 over y minus 2 plus c equal to 0. Right. Here roots are right. So 1 over y minus 2 equal to alpha. You can take the reciprocal. Then y minus 2 equal 1 over alpha. Here y minus 2 equal to 1 over beta. Now take the common denominator. Take the common denominator. Here y minus 2 square is the common denominator. Then a plus b into y minus 2 plus c into y minus 2 square equal to 0. Equal to 0. Now roots, we can write down the roots as y equal to take minus 2 here, then it will become plus 2. 1 over alpha plus 2, comma, y equal to 1 over beta plus 2. Right? Okay. Now let's multiply both sides by y minus 2 square. Then we can find the quadratic equation that we require. Right. So here, if you multiply both sides by y minus 2 square, then it will become a plus b into y minus 2 plus c into y minus 2 square equal to 0. Roots y equal to 1 over alpha plus 2, comma, y equal to 1 over beta plus 2. Right. Now expand and simplify the equation. If you expand this, a plus by minus 2b plus, you can simply expand this one, y square minus 4y plus 4 equal to 0. Equal to 0. Then simplify this, a plus by minus 2b plus multiply by cy square minus 4cy plus 4c equal to 0. Right. Now we can separate y square terms, y terms, and constant terms. So if you take y square terms, here cy square plus if you take y terms, by, here 4cy. Therefore, b minus 4cy plus the constant terms, a minus 2b plus 4c equal to 0. Right. Now here the roots are y equal to 1 over alpha plus 2, comma, y equal to 1 over beta plus 2. Here these are the two roots. Right. So this is the equation that we want. Cy square plus b minus 4cy plus a minus 2b plus 4c. Here roots are, these are the roots that we want. Right. So we can write down using x. Without using y, we can write down using x. So cx square plus b minus 4cx plus a minus 2b plus 4c equal to 0. Right. Here roots, x equal to 1 over alpha plus 2. Here x equal to 1 over beta plus 2. That is the final answer. Right. So I think now you have understood this part. But anyway, we are going to do another simple question. Right. First write down this. Right. Next question. Number 4. Fourth question. So now you see there is a small pattern in these questions. If you practice these questions more, you can easily get marks, right? These are the types of questions you will get in the A-level exam, right? And also we are going to do some past paper questions, but first we are going to do these questions, right? Write down next question, number 4. If the roots of the equation, ax square plus bx plus c, ax square plus bx plus c equal to 0 is alpha comma beta, then from that derive the quadratic equation, with roots 4 over alpha comma 4 over beta, in terms of simple a comma b comma c, right? In terms of simple a comma b comma c. Okay, right. Now you can do this question by yourself, because it is in the same pattern, right? This question also we can do like the previous 2 questions, right? So here roots are given. Roots are x equal to alpha comma x equal to beta, right? So here also I'm going to assume that y value. So let's assume y equal to 4 over x. Let's assume y equal to 4 over x. So then we can write down therefore when x equal to alpha. When x equal to alpha, we can write down the y value y equal to 4 over alpha. When x equal to beta, y value 4 over beta, right? So these are the 2 roots that we want, right? So from this algebraic relation, we can convert the x value to a y value. Then we can get the roots we want. Okay, right. Now look at this. So we know that y equal to 4 over x. Therefore, we can write down x equal to 4 over y. X equal to 4 over y. Then they have given that ax square plus bx plus c equal to 0. Here roots are x equal to alpha comma x equal to beta, right? These are the 2 roots that they have given, right? Now we are going to convert this x variable into y variable. We are going to convert this variable. So instead of x, write down 4 over y. Here a 4 over y square plus b into 4 over y plus c equal to 0. Here roots are, instead of x, write down 4 over y equal to alpha. Here 4 over y equal to beta. Now let's simplify. So here a into 4 square means 16 over y square plus b into 4 over y plus c equal to 0. Here roots we can cross multiply and take the y value. Y equal to 4 over alpha. Here y equal to 4 over beta. Right. Now take the common denominator. 16a plus 4by plus cy square. Here we have y square. And roots are the same. y equal to 4 over alpha, comma, y equal to 4 over beta. Now multiply both sides by y square. Then we will get the equation we want. Cy square plus 4by plus 16a equal to 0. Right? Here roots are y equal to 4 over alpha, comma, y equal to 4 over beta. Right? So this is the equation with this is the quadratic equation with root 4 alpha and 4 beta. So instead of y, we can write down the same equation using x. Same thing, right? So here we can write down cx square plus 4bx plus 16a equal to 0. Here roots we can write down as x equal to 4 over alpha, x equal to 4 over beta, right? So this is the final answer. Right, okay. Now I think you have understood this. Now let's do a simple question, but this is a little bit different from the questions we have done, right? After that, we can go to the past paper questions. Okay. First, write down this. Now, you have to follow this course. You have to follow this lesson completely. If you follow this lesson completely, you can achieve good results, right? Because we are going to do the theory part, then questions, and then past paper questions. If you practice more past paper questions, you can easily get more results, right? Okay. Right. Next question, number 5. Fifth question. Write down this question. So this question is a little different from the previous ones. Write down if the roots of the equation, x square minus bx plus c equal to 0. If the roots of the equation x square minus bx plus c equal to 0 is alpha comma beta, write down. Then find the quadratic equation. With roots alpha over beta, comma, beta over alpha. Then find the quadratic equation with roots alpha over beta, comma, beta over alpha in terms of b comma c. Right. Next, write down for the same question. Write down. Then from that, derive the quadratic equation. With roots alpha over beta minus 1, comma, beta over alpha minus 1 in terms of b comma c. Right. So here in this question there are two parts. First you have to find the, so using this equation you have to find the equation with roots alpha over beta and beta over alpha. That is the first part. Now second part, using this equation, using the second equation, not the first one, using the second equation you have to derive the third equation with roots, these two roots, right? So first part you have to find, second part you have to derive. Okay, now let's do this. Let's complete this question. Right. Here, this question says x square minus bx plus c equal to 0, roots alpha comma beta. That means x equal to alpha, comma, x equal to beta. Right. Now, sum of roots we can write down. We can directly write down the sum of roots alpha plus beta equal to negative value of the x coefficient. So minus b is the coefficient of x, negative value of that, divided by the coefficient of x square term plus 1. Right. comma, product of roots alpha beta equal to constant value divided by the coefficient of x square term plus 1. Right. So using these two, we can find the quadratic equation with roots. We can find the quadratic equation with roots alpha over beta, comma, beta over alpha. Right. So now here they are asking to, first step, they are asking to find the quadratic equation, not derive. So you can use the step-by-step method to find the equation, right? So we can use our formula x square minus sum of roots. Sum of roots means alpha plus alpha over beta plus beta over alpha into x plus the product of roots alpha over beta into beta over alpha equal to 0. Equal to 0. So x square minus, take the common denominator, alpha square plus beta square over alpha beta x plus 1 equal to 0. Now multiply both sides by alpha beta, then alpha beta x square minus alpha square plus beta square x plus alpha beta equal to 0. So this is the equation with roots alpha over beta and beta over alpha, but we have to express this in terms of b and c. Right. Right, so I'm going to erase this part. So here I can write down this equation as alpha beta x square minus alpha square plus beta square. I can write down that as alpha plus beta square minus 2 alpha beta x, right? So if you expand this, you will get alpha square plus beta square plus 2 alpha beta. So that plus 2 alpha beta and this minus 2 alpha beta will cancel. Then the remainder is alpha square plus beta square, same thing, right? Plus alpha beta equal to 0. So this equation you can write down in this way. Right. Now we can substitute the values of alpha plus beta and alpha beta. So we know that from the previous relation, alpha beta equal to c, cx square minus alpha plus beta equal to b, alpha plus beta equal to b. So here alpha plus beta square means b square minus alpha beta is c. So 2cx plus c equal to 0. Here roots are alpha over beta, comma beta over alpha. So this is the first part. That is the first part. So in the second part, they are asking to derive. In the second part, they are asking to derive the quadratic equation with roots alpha over beta minus 1, comma beta over alpha minus 1. Right, from this equation. So you have to use this equation to derive the second part. Right. So here roots are alpha over beta, comma beta over alpha. That means x equal to, here x equal to alpha over beta, comma x equal to beta over alpha. Right. So in the second part, they are asking for the roots alpha over beta minus 1 and beta over alpha minus 1. So if you take x minus 1 as a separate variable, then you can easily convert this equation to another equation, right? So look at this. Let's assume y equal to x minus 1, right? So here, if you assume y equal to x minus 1, then when x equal to alpha over beta, we get the y value as y equal to x minus 1. That means alpha over beta minus 1, right? When x equal to beta over alpha, we will get the y value as x minus 1. That means beta over alpha minus 1. So if you look at this is the roots that we want, right? So if you use this conversion, you can change this equation to the equation we need, right? First write down this, then we can continue. Right. Now now we can convert this x value to another value, right? So we know that y equal to x minus 1. Therefore, x equal to, if you take this 1 to the other side, x equal to y plus 1. X equal to y plus 1, right? So the given equation is cx square minus b square minus 2cx plus c equal to 0. So here roots are x equal to alpha over beta, comma x equal to beta over alpha, right? So now I'm going to convert the x value to a y value. So we know that x equal to y plus 1. Then c, instead of x, write down y plus 1 square minus b square minus 2c, instead of x, write down y plus 1 plus c equal to 0. Here also roots, instead of x, write down y plus 1 equal to alpha over beta. Here y plus 1 equal to beta over alpha. Right. Now let's expand this and find the answer. C, y plus 1 square, that means y square plus 2y plus 1 minus, expand this one, by square, b square y, this one is to this, plus b square minus 2c into y minus 2cy minus 2c into 1 minus 2c plus c equal to 0. Right. Now we can write down the roots. We can write down the roots. Take the plus value to here, plus 1 to the other side, then y equal to alpha plus beta, alpha over beta minus 1. Here y equal to beta over alpha minus 1. Right. Now simplify the brackets. Then you will get cy square plus 2cy plus c minus b square y minus b square plus 2cy plus 2c plus c equal to 0. If you simplify this, you will get cy square plus, here we have 2cy, that means 4cy. That means 4c minus b square y plus constant values are 2c plus 2c plus c. That means 4c minus b square equal to 0. Here roots are y equal to alpha over beta minus 1, comma y equal to beta over alpha minus 1. Those are the two roots. Right. Therefore, we can write down y as x, then cx square plus 4c minus b square x plus 4c minus b square equal to 0. Here roots we can write down x equal to alpha over beta minus 1, x equal to beta over alpha minus 1. Right. So that is the final answer. So first we have we found this equation using step-by-step method. Then using the formula, then we have found the last answer by changing this or by deriving the equation from this equation. Right. Okay. Right. So that's it. Now we can go to past paper questions. But before going to past paper questions, let's do a very simple question to remember the past theory parts, right? Let's do a very simple question. Then we can go to the past paper questions related to this. Okay. Let's write a very simple question. So this is from the basic theory parts. Write down a simple question. Find the intersection points. Find the intersection points of the quadratic function. Right. Find the intersection points of the quadratic function fx equal to 2x square plus 7x plus 3, 2x square plus 7x plus 3, and the straight line 2x minus y plus 3 equals 0. Find the intersection points of the quadratic function fx equal to 2x square plus 7x plus 3 and the straight line 2x minus y plus 3 equals 0. Write down. Then find the solutions. Or roots of the quadratic function y equal to fx. Right. So first I am going to draw this quadratic function. So in this quadratic function, they have given fx equal to x square plus 7x plus 3. So you can easily factorize this. So if you factorize this, factors are 2x plus 1, here x plus 3. So x plus 1, x plus 3. Right. So this is the quadratic function. Now you can find the intersection points of x-axis and y-axis. To find the intersection points of x-axis, we have to equal this function to 0. So when fx equal to 0, this part will be equal to 0. 2x plus 1 into x plus 3 will be equal to 0. Right. Then we can separate equal them to 0. 2x plus 1 equal to 0, comma x plus 3 equal to 0. Therefore, x equal to minus half, x equal to minus 3. So these are the intersection points of x-axis with this function. And same way, we can find the intersection points of y-axis. Right? That we can find when x equal to 0. When x equal to 0, we can find the intersection points of y-axis. Y equal to, so here 0, 0 plus 3. Y equals plus 3. Right? So next I am going to take the straight line. The given straight line is 2x minus y plus 3 equal to 0. So I am going to write this as y equal to 2x plus 3. So y is a function. I am going to write down that as gx. Y is a function. So I am going to write down y as gx equal to 2x plus 3. So this is a function. Right? So when gx equal to 0, this part will be equal to 0. That means x equal to minus 3 over 2. Right? Same way, when x equal to 0, y value is 3. Right? Y value is 3. Right? Those are the intersection points of x and y axis. Now we can draw the two graphs. Right? We can draw the two graphs. Now look at this. So this is the function. This is the function we are going to analyze. So this is the x-axis. So next straight line I am going to draw this. This is the straight line. Right. So now look at this. This is the function fx equal to 2x square plus 7x plus 3. Now this is the straight line gx equal to 2x plus 3. Now, if you look at this quadratic function intersects at 2 points. Here minus 3 and here minus half. Right? Right. Now, if you consider the second one, if you consider this straight line, the intersection points are minus 3 over 2. Minus 3 over 2. So these are the intersection points that we found. Now, if you want to find the intersection points of these two functions, if you want to find the intersection points of these two functions, this is the intersection point of these two functions, and here also we have another intersection point. There are two intersection points. This is the first one. This is the second one. Right. So we can find those intersection points by when we equal these two functions. Right. So when fx equal to gx, when fx equal to gx, 2x square plus 7x plus 3 equal to 2x plus 3. Right. Right. Now, here 3 and 3 will cancel. Then you can take 2x to the other side. Then 2x square plus 5x equal to 0. Right. Then you can take this x out of the brackets. Here we have 2x plus 5 equal to 0. Right. Then you can separately equal these two values to 0. Then from this we have x equal to 0, 2x plus 5 equal to 0. Then x equal to minus 5 over 2. Right. So this here we have minus 5 over 2, and here we have 0. Right. So the intersection points of these two functions are minus 5 over 2 and 0. That means the solutions to this equation. So this is the equation. When you equal these two, you get the equation like you get this equation, right? 2x square plus 5x. If you equal these two functions, you will get another equation 2x square plus 5x. So the solutions for that equation is x equal to 0 and x equal to minus 5 over 2. Right. So that is so the intersection points of these two functions means the solutions of this function. Right. So we have done these types of questions in the beginning of this lesson, but I have done this too. I have done this because you have to remember the past theories, right? That's all. Now let's do the past paper questions related to this. Right. Okay. Now let's do some past paper questions of the theory part we have done. So this is the end of this quadratic equation lesson. So we have done all the theory parts that is needed for the quadratic equations of A levels. Then after that we can go to the factor theorem and remainder theorem. Right. Before that we have to do some past paper questions in this lesson. Right. So first write down this. Let's do the 2007 A level question. 2007 PO paper essay question. First essay question, part A. Right. So write down 2007 A levels. 2007 A levels. Right. So write down the question. Write down alpha and beta. Alpha and beta are the roots of the equation. X square plus bx plus c equal to 0. Alpha and beta are the roots of the equation x square plus bx plus c equal to 0. Write down. Find the quadratic equation. Find the quadratic equation in terms of b and c. Whose roots are in terms of B and C, whose roots are alpha to the power 3, alpha to the power 3, and beta to the power 3. Whose roots are alpha to the power 3 and beta to the power 3. Next, write down, hence find the quadratic equation. Hence, find the quadratic equation in terms of B and C. In terms of B and C, whose roots are alpha to the power 3 plus 1 over beta to the power 3, comma, beta to the power 3 plus 1 over alpha to the power 3. Right? So these are the roots. So first they have given a equation, quadratic equation, x square plus bx plus c with roots alpha and beta. Right? Now, second part first part they are asking to find the quadratic equation with roots alpha to the power 3 and beta to the power 3. They are asking to find the quadratic equation. That means you have to do you have to simplify that using the formula we have given. Then in the second part they are asking, hence find the quadratic equation. Hence find means you have to derive. Hence find means you have to derive the quadratic equation of the roots alpha to the power 3 plus 1 over beta to the power 3, comma, beta to the power 3 plus 1 over alpha to the power 3. So you have to derive the quadratic equation with these roots. First you have to find the quadratic equation with these roots, then you have to derive the second part. Right. So the same as the theory part we have done, you can easily do this question. Now let's see how to do this. Right. So first equation they have given x square plus bx plus c equal to 0. Here roots are x equal to alpha comma x equal to beta. These are two roots. Right. These are the two roots that they have given. Right. Now we can directly write down the sum of the roots alpha plus beta. We can write down minus coefficient of x b over coefficient of x square term is 1, comma, alpha beta constant term over coefficient of x square term 1. Right. These are the two roots. These are the two values, alpha plus beta and alpha beta. Now let's find the quadratic equation. Quadratic equation with roots alpha to the power 3, comma, beta to the power 3. Right. Now let's write down x square minus sum of roots alpha to the power 3 plus beta to the power 3 into x plus product of roots alpha to the power 3 into beta to the power 3 equal to 0. Right. Then we can simplify and find the answer. Right. So here x square minus alpha to the power 3 plus beta to the power 3. So in O levels you have done this formula, a to the power 3 plus b to the power 3. You can factorize this. How to factorize this? You have to first forget the power, then write down the first factor as a plus b. Forget the power. Then second one, you have to take the square of the first term, a square. If you have plus here, take minus. First term into second term plus square of the second one. Right. Same way, if you have a to the power 3 minus b to the power 3, you can write down first forget the power, then first factor a minus b. Second factor, take the square of the first one. If you have minus, change this to plus ab plus square of the second one, b square. Right. So in this way, you can factorize these two relations. These two expressions you can factorize. Right. Now same way you can factorize this. Now we can write down first factor alpha plus beta, second factor alpha square. If you have plus minus alpha beta plus beta square into x. plus here we can write down alpha beta to the power 3 equal to 0. Right? Okay. Now here we have x square minus alpha plus beta. This factor I can write down alpha square plus beta square. I can write down as alpha plus beta square of the whole thing minus 2 alpha beta and the remaining alpha beta into x plus alpha beta to the power 3 equal to 0. Right? So if you expand this alpha square, we get alpha square, beta square, we get beta square, plus 2 alpha beta will cancel with minus 2 alpha beta. Then minus alpha beta is here. So this is same as this one, right? Same as this one. Now we can simplify this. Now we can write down x square minus alpha plus beta into alpha plus beta square minus 3 alpha beta x plus alpha beta to the power 3 equal to 0. Right, so this is the equation with roots alpha to the power 3 comma beta to the power 3. Now we can write down alpha to the power 3 beta to the power 3 with using b and c. So I'm going to write down this. Right, so here we have x square plus alpha beta into alpha beta square minus 3 alpha beta x plus alpha beta to the power 3. Now we can replace this with the first two relations we got. Now we know that alpha plus beta is equal to minus b. Therefore, we can write down x square minus, instead of alpha plus beta, I can write down minus b into, here we have alpha plus beta square. Instead of alpha plus beta square, we can write down minus b square. Right? Minus 3 alpha beta. Now we know that alpha beta is equal to c from the previous relation. Therefore, 3c x plus alpha beta is c. Therefore, c to the power 3 equal to 0. C to the power 3 equal to 0. Right. Now let's simplify this. So if you simplify this, you will get x square minus c minus plus b square minus 3c x plus c to the power 3 equal to 0. Here roots are x equal to alpha to the power 3 comma x equal to beta to the power 3. Right, so this is the final answer. That is the final answer. Now in the second part, so in the first part you can easily prove using the formula. Right, in the second part they are asking the quadratic equation with roots. In the second part they are asking quadratic equation with roots alpha to the power 3 plus, with roots alpha to the power 3 plus 1 over beta to the power 3 and beta to the power 3 plus 1 over alpha to the power 3. Right, so how to do this? So here we can, right, so look at these two. Now you have to, first part you have to find, second part you have to derive this part. So I'm going to take the common denominator of this. If you take the common denominator, we get alpha to the power 3 beta to the power 3 plus 1 over beta to the power 3. Here also we get alpha to the power 3 beta to the power 3 plus 1 over alpha to the power 3. Right? Okay. Right. Now here we know that alpha beta is equal to c. Alpha beta is equal to c. Therefore, we can write down this as c to the power 3 plus 1 over beta to the power 3. Second root c to the power 3 plus 1 over alpha to the power 3. These are the two roots. Right. Now we know that c to the power 3 plus 1 is a constant. C is a constant, right? So we can take that. We can take right. Let c to the power 3 plus 1 equal to k. Right? K is a constant. Right? K is a real value. Right? So let's take c to the power 3 plus 1 equal to k. Then we can write down these two roots as k over beta to the power 3, comma k over alpha to the power 3. Right? Now this is a very simple format compared to the given format. So we have simplified the format of these roots. We have taken the common denominator. Then we have taken this as a constant because c is a constant. Now we can express these two roots as k over beta over 3, comma k over alpha to the power 3. Now we just have to find the quadratic equation with these two roots. Right. Now look at this. Right. Now let's assume y equal to k over x. Right. Let's assume this. Now we know that in the previous equation, x is equal to alpha to the power 3 or x equal to beta to the power 3. Now when x equal to alpha to the power 3, y equal to k over alpha to the power 3. When x equal to beta to the power 3, y will be equal to k over beta to the power 3. So these are the two roots that we want. Therefore, from this conversion, we can convert our second equation to the equation we want. Right? Okay. Now let's do that. Right. So our second equation was x square plus b into b square minus 3c x b square minus 3cx plus c to the power 3 equals 0. Plus c to the power 3 equals 0. Right? Here roots are x equal to alpha to the power 3, comma x equal to beta to the power 3. These are the two roots. Right. Now we know that y equal to, we took that y equal to k over x. Therefore, x will be equal to k over y. Right? Then we can write down this as k over y square plus b into b square minus 3c. Instead of x, again we can write down k over y plus c to the power 3 equals 0. Right? So here also we can change the roots. Instead of x, write down k over y equal to alpha to the power 3, k over y equal to beta to the power 3. Now let's simplify this. So here we have k square over y square plus b square minus 3c k over y plus c to the power 3 equal to 0. Now equal to 0. Right. So roots will be take the reciprocal and take cross multiply this. Then you will get y equal to k over alpha to the power 3, comma y equal to k over beta to the power 3. Right. Now multiply both sides by y square. Then you will get k square plus b square minus 3c into k plus into ky plus c to the power 3 y square equal to 0. Right? So here you can write down the roots. You can write down the roots. Y equal to k over alpha to the power 3, comma y equal to k over beta to the power 3. Right. Now here we know that k is equal to c to the power 3 plus 1. Right. We know that k is equal to c to the power 3 plus 1. Therefore, we can write down. So we can write down the equation. So this is the final equation, but we have k here. Right. So answer is c to the power 3 y square plus b into b square minus 3c. Here k is equal to c to the power 3 plus 1. Here k is equal to c to the power 3 plus 1 y plus k is equal to c to the power 3 plus 1 square equal to 0. Right. So here roots are y equal to k means c to the power 3 plus 1 over alpha to the power 3. Here y equal to c to the power 3 plus 1 over beta to the power 3. Right. Now we know that here y equal to c to the power 3 means alpha to the power 3 beta to the power 3 plus 1 over alpha to the power 3. Here also y equal to c to the power 3 means we know that alpha to the power 3 beta to the power 3 plus 1 over beta to the power 3. Now if we divide this separately by alpha to the power 3 and here beta to the power 3, we get the we get the roots we want. Right? Therefore, roots we want, we get if you divide by alpha to the power 3, beta to the power 3 plus 1 over alpha to the power 3. Here we get alpha to the power 3 plus 1 over beta to the power 3. Right? So here equation is c to the power 3 y square plus b into b square minus 3c into c to the power 3 plus 1 y plus c to the power 3 plus 1 square of the whole thing equal to 0. Right. Now this is the final answer. So you can keep the final answer in terms of x. So c to the power 3 x square plus b into b square minus 3c c to the power 3 plus 1 x plus c to the power 3 plus 1 square equal to 0. Here we can write down roots. X equal to b to the power 3 plus 1 over alpha to the power 3, comma x equal to alpha to the power 3 plus 1 over beta to the power 3. Right. So in this way, we can complete the given problem. Right. So this is the 2007 A-level problem. Okay. Right. So as you see, we can this is similar to the questions we have done previously, right? So in the A-levels also you will get a similar type of question, but there are some different questions too. So we are covering all the types of questions, but not in this, not today. Today we are doing several past paper questions. Then next in the next lesson we can complete another set of questions. Right. So let's do another question. Write down the next one. Next question, 2008 A-level. Let's do 2008 A-level question. Right. So this question is also similar as the 2007 question. Right. Write down 2008 A-level. Yeah, write down alpha and beta. Alpha and beta are the roots of the equation. Write down 2008 A-level question. Alpha and beta are the roots of the equation x square plus bx plus c equal to 0. X square plus bx plus c equal to 0. Where c is not equal to 0. Where c is not equal to 0. Then write down, find the quadratic equation. Find the quadratic equation in terms of b and c. In terms of b and c, whose roots are alpha to the power 4 and beta alpha to the power 4 and beta to the power 4. Whose roots are alpha to the power 4 and beta to the power 4. They write down, hence find the quadratic equation. Hence find the quadratic equation in terms of b and c. In terms of b and c, whose roots are alpha to the power 4 over beta to the power 4 plus 1, comma beta to the power 4 over alpha to the power 4 plus 1. Right. So here also we have two parts. First, they have given a quadratic equation and the roots are alpha and beta. Right. So using this quadratic equation, you have to find the quadratic equation with these two roots. Then second part, you have to derive. Hence means derive. You have to derive the quadratic equation with these two roots. Right. Let's see how to do that. Right. So this is the equation they have given. X square plus bx plus c equal to 0. Here roots are x equal to alpha, comma x equal to beta. These are the two roots. Right. So if you take the sum of roots, alpha plus beta equal to here minus b over 1, alpha beta equal to c over 1. Right. Now you know the method. We can derive the quadratic equation with roots alpha to the power 4, comma beta to the power 4. Alpha to the power 4, comma beta to the power 4. Right. So we can write down x square minus sum of roots alpha to the power 4 plus beta to the power 4 into x plus product of roots alpha to the power 4 into beta to the power 4 equal to 0. Right. Now we can simplify this. X square minus. So here we can write down this as alpha to the power 4. We can write down alpha square plus beta square x plus alpha beta to the power 4 equals 0. So here we can use this formula. We know that, right? We know that a plus, right? Now look at this. We know that a plus b square equal to a square plus b square plus 2ab, right? So if you take 2ab to the other side, then a square plus b square equal to a plus b square minus 2ab, right? So here this alpha square acts as a, and here this beta square acts as b. So you can use this formula, then write down this part in this way, right? So we can write down x square minus this one, we can write down alpha square plus beta square of the whole thing minus 2 times AB. That means alpha square into beta square into x right? Uh, plus alpha beta to the power 4 equal to 0, right? Equal to 0. Right. Okay. Now, right now, same way we can write down this alpha square plus beta square. We can write down that part also using the same method, right? So here we can write down x square minus alpha square plus beta square. That we can write down as alpha plus beta square minus 2 alpha beta. Square minus 2 alpha square beta square x plus alpha beta to the power 4 equal to 0. Right. Now, now look at this. Now, if you expand this, you will get alpha square beta square plus 2 alpha beta. So plus 2 alpha beta and minus 2 alpha beta will cancel. So from this you will get the same value. From this you will get the same value as this, right? Then you can write down this using B and C in terms of B and C, right? Now look at this x square minus inside the brackets alpha plus beta. We know that alpha plus beta is equal to minus b. So minus b square minus 2 alpha beta. We know that alpha beta is equal to c. Then here we have 2c square of the whole thing minus 2 alpha square beta square minus, that means minus 2c square into x plus alpha beta means c to the power equal to 0. Right. So if you simplify this, you will get x square minus b square minus 2c square of the whole thing minus 2c square x plus c to the power 4 equal to 0. Right? C to the power 4 equal to 0. Then look at this now. Then we can expand this x square minus, if you expand this, you will get b to the power 4 minus 4 times cb square plus 4c square minus 2c square into x c to the power 4 equal to 0. Therefore, we can write down x square minus b to the power 4 minus 4cb square plus 2c square into x plus c to the power 4 equal to 0. Right? So this is the equation. So here roots are alpha to the power 4, comma beta to the power. These are the roots. Right. Now, from using this equation, now we have found the equation with roots alpha to the power 4, comma beta to the power 4. Now, using this, we can find the equation. We can derive the second equation, right? Okay. Right. So, second equation. Let's derive the second equation. Right. Now, they are asking to find the quadratic equation, derive the quadratic equation with roots alpha to the power 4 over beta to the power 4 plus 1 comma beta to the power 4 over alpha to the power 4 plus 1. Right. Now, if you take the same, if for as the previous question, you can take the common denominator, then alpha to the power 4 plus beta to the power, here beta to the power, here I can write down alpha to the power 4 plus beta to the power 4, here alpha to the power, right. So here I can write down alpha to the power 4 plus beta to the power 4 is equal to a constant. I can take this part as a constant because it is equal in both of the rows, right? So if this is a constant, we can write down a over beta to the power 4, comma a over alpha to the power 4, right? So using this, I can write down an algebraic expression y equal to a over x. Now, if you so if you know that x equal to alpha to the power 4, right? So when x equal to alpha to the power 4, you will get the first root. When x equal to beta to the power 4, you will get the second root, right? So let's find the roots. So when x equal to alpha to the power 4, you will get y equal to a over alpha to the power 4. When x equal to beta to the power 4, you will get y equal to a over beta to the power 4. So these are the roots we want, right? So from this algebraic expression, you can get the roots we want. So we can convert our equation from x to y. Then we can find the answer. Right. Now let's write down the equation. So we know y equal to a over x. Therefore, x equal to a over y. So our equation was x square minus right p to the power 4 minus 4 cb square plus 2c square into x plus c to the power 4 equal to 0. Right. Roots alpha to the power 4 comma beta to the power 4. Right. So then we can write down. So here this part we can write down as alpha to the power 4 plus beta to the power 4, because we know that here we have the sum of roots. So we have taken this part as capital A. So we can rewrite our equation x square minus ax plus c to the power 4 equal to 0. Here roots x equal to alpha to the power 4 comma x equal to beta to the power 4. Now I am going to convert x into y. Then a over y square minus a over a into a over y plus c to the power 4 equal to 0. Roots a over y equal to alpha to the power 4, a over y equal to beta to the power 4. So if you simplify this, you will get a square over y square minus a square over y plus c to the power 4 equal to 0. Right. So here roots, you will get the roots y equal to a over alpha to the power 4, y equal to a over beta to the power 4. Right. Now you can simplify this and get the answer. It is simple. So if you multiply both sides by y square, you will get a square minus a square y plus c to the power 4 y square equal to 0. Right. So the roots are y equal to a over alpha to the power 4, y equal to a over beta to the power 4. Right. So we know that c to the power 4 y square minus, we know that a value of a, right? We know that value of a. So here we can write down, I am going to write down a square y plus a square equal to 0, roots y equal to the roots we want, b to the power 4 over alpha to the power 4 plus 1, comma, y equal to alpha to the power 4 over b to the power 4 plus 1. Right? So we know the value of a. So we have to write down the value of a here. So I am going to convert this into x c to the power 4 x square minus a square x plus a square equal to 0. Here roots we can write down as x equal to b to the power 4 over alpha to the power 4 plus 1, x equal to alpha to the power 4 over b to the power 4 plus 1. So this is the final answer. Right? This is the final answer. So in this way, you can complete the A-level questions. Right? So in the next class, we will do another set of questions, and then we can go to the next part of our lesson. So